Hello everyone! We discuss a light-hearted topic today. Based on the known composition of the solar system, we can estimate the overall mass of the solar system. Here, we assume it is the Sun. The distance between the Earth and the Sun is very far. Assume the Earth is at this position. This is the Earth. This distance is 150 million kilometers, which is an astronomical unit. It takes 8 minutes for sunlight to reach the Earth. Of course, we already feel it is very far away. Further away, outside our Earth's orbit, is Mars. Outside Mars' orbit is the asteroid belt. The asteroid belt is quite wide, to a place more than 5 astronomical units away from the Sun. It is the orbital region where Jupiter is located. It is 5.2 astronomical units away from the Sun. It is already much farther from the Sun than our Earth is. More than 5 times the distance from our Earth to the Sun. Saturn is even further away from the Sun. The distance between Saturn and the Sun is almost twice as far as Jupiter. There is a vast space between Saturn and Jupiter. The distribution law of these 8 planets is that the distance from the Sun is increasing rapidly. The distance is increasing at an accelerating rate. Basically, the major planets. The degree of emptiness around the major planets is increasing. Uranus and Neptune. Assuming this is Neptune, it is nearly 30 astronomical units from the Sun, which is already very far. When sunlight shines here, the light is already very weak. This is Pluto. There are other celestial bodies, such as Jupiter and Saturn's moons. They contain a lot of water molecules, like Jupiter and Saturn. A considerable part of their moons are made of water, or it is composed of solid water. So, starting from Jupiter, the water content gradually increases. It starts from here. The water content gradually increases. In fact, to Neptune, the water content will further increase. And then here, for example, at 50 astronomical units. At 50 astronomical units here, the water content will further increase. Even up to the position of 100 astronomical units, the water content will further increase. That is in this region. The main component of the matter of the celestial bodies here is water. This is the main composition of celestial matter in this region. We speculate that hydrogen is the most abundant element in the entire universe, followed by helium. These are the 2 elements with the largest proportion. The rest are secondary, and the remaining oxygen elements, carbon element, and nitrogen, neon element. But these are relatively more. These are the top 4 most abundant elements. Although oxygen can rank 3rd, but it is relative to hydrogen and helium, are much smaller, which can be ignored. The content of carbon element is even lower than that of oxygen element. Hydrogen is everywhere in the universe. Therefore, hydrogen and oxygen have ample opportunities for chemical reactions, so HO is generated. In fact, hydrogen also reacts with carbon to form methane, which is methane. This is methane, since the content of carbon is half that of oxygen. In our universe, the content of water should be more than that of methane. Maybe the content of water is the content of water molecules, twice that of methane molecules. It's just twice as much. 2 water molecules correspond to 1 methane molecule. For the entire universe, they should be in this proportion. Thus, we can see that the content of methane in the universe is also very large, because we know that water is everywhere. On our Earth, the methane content is very low. In fact, at the orbital positions of Saturn and Neptune, the methane content gradually increases. But within this distance, within 50 astronomical units, water is still the main component. Methane is very secondary, because methane has a lower melting point, and the melting point of water is relatively high. So, the farther from the Sun, the lower the temperature. In this range, at 50 astronomical units, in this range, is more suitable for the generation of water and solid water. So a large amount of solid water accumulates here. We know that comets are mainly composed of water. Comets mainly come from here. Comets mainly come from the vicinity of 50 AUs. So we can infer that, within 100 or 200 astronomical units, there may be methane-dominant planets. That is to say, mainly methane. The farthest distance from the Sun should be dominated by methane. There will be solid planets, planets dominated by methane. Just like within 50 astronomical units, it forms numerous planets composed of water. Planets dominated by water, such as Pluto. The main component is water, solid water. So, in further distances, maybe at 200 astronomical units, in this region, it will be dominated by methane. Planets composed of solid methane will dominate. So, in the area far from the Sun, methane will be the main component. In further distances, maybe other elements will be the mainly composed of elements with lower melting points, or in other words, mainly composed of hydrogen and helium elements, at a further distance from the Sun, such as 1,000 astronomical units, even at a place 10,000 astronomical units away. Farther away, it is mainly composed of hydrogen and helium elements. The temperature there may be very low. There will be solid hydrogen or solid helium. So the planets there should contain a large amount of solid hydrogen and helium. The planets there, the temperature is almost close to absolute zero. If they are really close to absolute zero, then they will contain a large amount of solid hydrogen and solid helium. Which is solid hydrogen of hydrogen, and solid helium, and inert elements. So, beyond our Sun and 8 planets, in fact, there are many other celestial bodies in the entire solar system. This location is dominated by celestial bodies composed of water. Further away, the regions become dominated by methane celestial bodies. A place farther from the Sun, it became a celestial body mainly composed of hydrogen and helium elements. Of course, our Sun is dominated by hydrogen and helium, but the Sun is gaseous. A place farther from the Sun, they are celestial bodies mainly composed of solid hydrogen and helium elements. Our conclusion is that the mass of the entire solar system is very large. In addition to the Sun and 8 planets, there is still a lot of mass. These countless celestial bodies added together, their mass is likely to be more than twice the mass of the Sun. Even in the very far away places from the Sun, they still belong to the solar system, because the scale of the solar system can reach 1 light year. In such a vast area, the mass is twice that of the Sun. That is to say, the mass of a solar system is actually 3 times that of the Sun. That is to say, the mass of our solar system is actually about 3 times that of the Sun. The mass of the solar system is more than we think. Although the combined mass of the 8 planets and the Sun accounts for over 99%, which is 99.86%. This is the common data we know. But in fact, the Sun only accounts for 1/3 of the mass. That is to say, according to the distribution of elements and physical properties of elements, we can infer the mass of the solar system. This is an idea. Through this idea, we can feel that the mass of the Sun is much larger than we feel now. This is actually also a logic that is beneficial for the solar system to have a larger mass.